Astronomers have a problem when it comes to the mass in the universe, a lot of it is missing. You may know about dark matter, the enigmatic substance thought to make up 27% of the universe, but this isn't the only mysterious absence. When it comes to normal matter, the stuff we're made of including protons, neutrons and electrons, there's also a chunk missing. In fact, models of the universe hint there should be about twice as much matter as we can see. This is called the missing baryons problem. Now, 2 papers have come out suggesting we may have found half of this missing chunk, in huge stretches of hot, diffuse gas that hold galaxies together. The particles in this gas are baryons, particles made up of 3 quarks, like protons and neutrons. 2 teams, who both separately uploaded papers to the R14 preprint server in September, found these baryons using an effect called Sunyaev-Zeldovich. This effect is essentially light left over from the Big Bang scattering off the particles in the gas. When this happens, it leaves a trace in the cosmic microwave background CMB, the relic radiation from the earliest universe seen from across space. This result establishes the presence of ionized gas in large-scale filaments, and suggests that the missing baryons problem may be resolved via observations of the cosmic web, said the authors of the second study. The missing baryon problem is solved, claims Hideki Tanamura at the Institute of Space Astrophysics in Orsay, France, leader of one of the groups. The result is not surprising from a theoretical perspective, as filaments of gas linking galaxies together have been predicted for years, through models that have been developed and compared with observation. One of the theories that makes these filaments' existence likely is dark matter, for example. But the ability to look using the Sloan Digital Sky Survey data and identify the missing mass is a big step. Everybody sort of knows that it has to be there, but this is the first time that somebody, 2 different groups, no less, has come up with a definitive detection. Professor Ralph Kraft, from the Harvard-Smithsonian Center for Astrophysics in Massachusetts, who wasn't involved in the studies, told New Scientist. This goes a long way toward showing that many of our ideas of how galaxies form and how structures form over the history of the universe, are pretty much correct. The 2 studies are not published in peer-reviewed journals yet, and more results need to be collected before we have a clear understanding of exactly how much of the universe's matter is hiding in these filaments. A better understanding of the distribution of mass throughout the universe will help astronomers building models of dark matter and dark energy, 2 of the biggest mysteries in astronomy right now. While the result does not account for all of the missing matter, it is strong evidence our models of the universe are pointing in the right direction.